In this video, we will solve this differential equation. Let me write down some formulas that we'll be using here. We have this formula, UA of t, f of t minus a is e to the negative as, Laplace transform of f of t. We will also need this formula, e to the at is equal to 1 over s minus a, and the Laplace transform of t times e to the at is 1 over s minus a squared. Okay, then as always, we start by computing the Laplace transform on the left and on the right. The Laplace transform of the derivative is s times the Laplace transform of the function minus y of 0, which is 9, then minus 5 times the Laplace transform of y, and this is equal to 4 times, when we apply this function, this formula, then we get that this is 4 times e to the negative a is 2s times the Laplace transform. We have to compute the original. This is the u2 shifting of what function? The answer is, we forget about this part, and then we change t by t plus 2. Then we get 4 times e to the phi t. Okay, then we can continue. Here we have s minus 5 times Laplace transform of y. We're going to move the 9 to the right, and equal to 9, plus e to the negative 2s times, and the Laplace transform, sorry, I wrote down the 4 twice. Then the Laplace transform of this is 4 over s minus 5. And then we can solve for Laplace transform of y by dividing by s minus 5. Then I get here, I get s minus 5. And when I divide by s minus 5, I get this square. Now we get that the Laplace transform of y, this is the Laplace transform of 9 e to the phi t. And in order to compute the Laplace transform inverse of this part, we need to apply this formula from right to left, and then we need to visualize this part, right? We need to visualize the part that is multiplying e to the negative as. We need to visualize it as the Laplace transform of a function. But then the question is, what function has the property that the Laplace transform of the function is 4 over s minus 5 squared? And if we look at this formula, we see that that function, you can see this as the Laplace transform of t times 4 times e to the phi t. Then we have that this is plus e to the negative 2s, Laplace transform of 4t e to the phi t. And then this is just the Laplace transform of 9 e to the phi t plus, and applying this formula, we get that this is u2 of t times, anytime I see that t, I replace it with t minus 2. We get times 4 times t minus 2 times e to the phi times t minus 2. That means that the answer, the solution of this differential equation, when we compare this part, Laplace transform of y equal to the Laplace transform of this function, and we get that our y is y equal to 9 e to the phi t plus u2 of t times 4 times t minus 2 e to the phi times t minus 2. This is the solution. As we have pointed out before, in this procedure we have to compute two Laplace transform inverse, the Laplace transform inverse of this part, which is 9e to the phi t, and the Laplace transform inverse of this part, which was 4t e to the phi t, and this part is responsible for this part of the answer, and this part is responsible of a part of the answer that has a heavy side function. Okay, I think this is it for this video.